talk a little bit about the vectors. Today is a good day to take notes. As I'm doing them, I'm going to talk a little bit about things that you can do with vectors. There are two-dimensional vectors. Bless you. Two-dimensional vectors, I kind of talked about it the other day. If you look at the tile on the floor, a two-dimensional vector would literally be drawn on the tile. Whereas a three-dimensional vector would be on the tile and then straight up to the air. Okay, so typically at this level, you're going to work with three-dimensional vectors. They're actually easier to work with.
Yeah.
So I'll give you an example. I'm going to call one of them A, and A is going to be 2, 2, 0. And then I'm going to talk about B. And those are 13, 5, and 4.
So for a two-dimensional vector, would the J always be 0? Like the up?
They don't even have a J. I mean a K. They don't have a
Oh
K.
yeah, the K.
They would have an I and a J only.
So the K would just be 0.
Gone. It would be not even there.
Oh.
Not even there.
Okay.
So yeah, the first thing I want to talk about is how do I take this and rewrite it into the vector form. So we talked about that the other day, and you kind of gave us some insight as to the letters. So the top guy pairs up with I. The middle guy pairs up with J. And the last guy here is going to pair up with K. So this can also be written in that format. So there's two ways to write the vectors. Oftentimes they're going to give it to you this way, but occasionally they'll throw this one in and then make you kind of work that process. Okay, so go ahead and write B for me in the IJK form.
Are there ever like vectors that have like a negative I or negative J?
Yeah.
So will they include that like in the parentheses?
It would be like a negative 2.
Okay.
Yeah. So I can't draw it. If you look at your fingers, okay, you have your X and your Y, also known as your I and your J and your K. However, this line here could come back this way. This line here could come back this way, and then this one could go straight down as well. So if I'm thinking about it in that aspect, this would be positive, this would be negative, this would be positive, backwards would be negative, and then last but not least, this would be positive or negative. So it is a three-dimensional object, so it doesn't stop on the tile on the floor, it would go down as well. Is that better? Okay. Okay, so the next thing we're going to do is you're going to write this guy out in your 13i plus 5j plus 4k, right? So that's B. All right, so the things that I started to talk about, maybe I didn't get very good into them, are how to find the length of a vector, also known as the magnitude. Magnitude and length are one and the same, okay? So if I'm looking to find the length, it's going to be written as an absolute value symbol, and it's going to be the square root of the first guy, I stuff, not including the letter I, the next one, and the next one squared. So it's going to be 2 squared plus 2 squared plus 0 squared. So the length of this is going to be 4 plus 4 plus 0, the square root of 8. So you can leave it like the square root of 8, you can clean it up a little bit to be 2 squared to 2, however you choose to do that. So your length is each of the individual pieces, regardless if it's two-dimensional or just three-dimensional, square it, add them up, square root it. All right? Could you do me a favor and find the length of B, please? I thought so. This is the length of B. 13 squared plus 5 squared plus 4 squared. Seems nice and big. Does anybody have it?
210.
210?
Like the square root of 10.
Okay.
Yeah.
Cool, thank you. All right, how do we feel? Good? Yes, no, maybe so, yes. Okay, so, we talked about that. The next thing I wanna talk about is something called the unit vector. The unit vector, let me start with this. When I show you my little drawing and my finger and such, it all starts at the origin. Does that make sense? So like, I can't draw the darn thing, but you have your I, your J, your K, but your origin is at the point 0, 0, 0. So what these are called are position vectors. So this goes to, from the origin, in the direction of I, and then 2 in the direction of J, and then up 0. Does that make sense? So these are what we call position vectors because they start at the origin. Okay, so kind of keep that in mind. When you're given them like this, that just means it's starting where I need to start. And I'll show you the difference in a minute when they're not position vectors and they're vectors out in space. Alrighty? So having said that, the unit vector, we're going to try to find the unit vector. What would be the simplest form of that particular vector? So bring it back to the original, what the unit would have been. And the formula for that is going to be 1 over the length times the actual vector itself. Sometimes they just put a U in there, but I think you understand this is like your IJK. So if I asked you to find the unit vector of A, right, A was 2, 2, 0. To find the unit vector, we've done the legwork, we've found the length of it, and the actual vector itself was 2, 2, 0. You can leave it like that, you can distribute that square root of 8 through if you so choose, or you just leave it like that. So if you decided to, just to show you, 8, the square root of 8 is 2 square roots of 2. Is everybody cool with that? And I would be multiplying it by 2, 2, and 0. So what would, if I cleaned it up, which I don't have to, but if I did, do you agree it would be 1 over the square root of 2, 1 over the square root of 2, and then 0? Because the 2's would cancel, the 2 would cancel, and then I'd have 0 times anything is 0. However, this is perfectly fine, the unit vector. Are we good? Yeah.
Will they ever ask for it simplified like that?
No.
To me, if you've gotten to the point where you have it, you're good. Okay, are we cool so far? Now, let's go ahead and do me a favor and find the unit vector in the direction of B as well, just for practice purposes. Find the magnitude of this unit vector, if you don't mind. What do I mean by magnitude? The length. Find the length of this unit vector for me, if you don't mind.
Does it have a name or something? What variable should be used to solve for it? Like, because we have an A and a B. Would this be like the
Call.
vector?
Yeah, you can call it U. Yeah. The magnitude of this guy? How's it going? You get it? No? Got it? Got it? Got it?
So what
Yes.
is the magnitude again?
The length of it.
The length of the unit vector? Okay.
The length of any vector.
Oh,
So-
okay.
This, square root of 210, is the length of this vector.
Mm-hmm.
This is the length of this vector. So I just asked you, find the unit vector of A, and we went through the process of finding the length of this unit vector. Did everybody get the number 1? Okay. Also do me a favor and find the length of the unit vector for B. What are you getting? So the length of any vector that's a unit vector is going to be what? 1. What does the word unit mean? It means 1. So what this is this is the most basic vector that comes off of any vector. Let me explain what that means. If I was to say that I had this vector, right? Okay, a position vector starts here, moves its way out in the world. It could be any length at all, could be any magnitude at all. If I find the unit vector, it's always going to be that same direction, that same one, however, a mini version of it that always is a length of 1. It's the most basic of that vector. It's the one that has the length of 1 every time. So what a unit vector does is it takes whatever vector you have in space and it brings it back to what the original vector would have been with a length of 1. Is everybody okay with what I just said? So it's a mini version of that vector. However long that vector is, it takes it back to the vector that has a length of 1 every time. Are we cool? Never ever are you going to have to answer why the unit vector is what it is. They just are going to be like, find the unit vector. But now you have an idea. It's a vector that's created from whatever vector you have to be its most simplistic version. Okay? Are we cool with that? No? Yeah, we love that. Okay, now, having said that, these are two vectors in space. Can we find the angle between those two vectors? So let's say we've got vector 1, that's here, we got vector 2, that's here, it's not that, but can we find the vector between? So I gave you that formula the other day, it's on your bright colored sheet of paper, it is written in a very strange way. I'm not a fan of it. Question is going to be asked of you, it's never going to be find the angle between two vectors. It's going to say use the scalar product to find the angle. So the scalar product is the name that they give it. The way that they give it on there is this, I think. If you can read between the two lines, do you see what I'm saying on your bright colored sheet of paper down on vectors? So that is the actual formula, the way they give it to you. They do have this in the middle, and I'll explain this. I think this is what they say on it. Is that how they give it to you? Yeah. So really, it's like the commutative. It's like the reflexive property, actually. Whatever property. This guy is equal to this, right? And then this guy is also equal to this. So that's basically what it's saying. What the heck does this mean? That's just the ability to multiply two vectors. So if I'm looking at these two vectors that we started with, let's say I have A is 2, and then 2 and 0, and then let's say I have B is still the 13, 5, and 4. If I wanted to find the angle that's formed between these two vectors from the origin, so where they start, where they go out, and that vector that falls in between them, that angle that falls in between them, the way I would do it, I, on a personal level, would prefer to write it like this. Cosine of theta is equal to the dot product divided by the length of A and the length of B. Do you see that that's a version of that, or not at all? Are we cool? Like if this was gone, and I solved for cosine theta, do you agree that that's exactly what I wrote up there? So back in the dark ages when I learned math, that was the way it was presented. Now it's presented, it's funny because a 6th period they used my classroom, and the gentleman that came up also had a degree in math, and he was like, who does it that way? I said, I know, it's so strange. So we both were taught many moons ago. So here's how this works. We're going to find the dot product, and what dot product is this guy right here. The dot product is another way of saying I am going to multiply. And the way that you dot product something is you take the things that belong together for I, the things that belong together for J, and the things that belong together for K, and then you multiply them individually. So in example, for the dot product here, A dot B would be 2 times 13, top times top. So 2 times 13 plus 2 times 5 0 times 4. That's what we call the dot product. It's the multiplication of two vectors. So what is A dot B in this particular case?
36.
26 plus 10 plus 0, so 36. Are we cool? How do I find the angle between the two vectors? We find the dot product, and then we have cosine of theta is equal to the dot product divided by the length of each of those vectors. That's what these guys are saying, it's the magnitude. So we just did it. A was the square root of 8, and then B is the square root of 210. Things to know when we're doing this math, you have to be in degree mode. So degree mode. Make sure your calculator's in degree mode. And does it make sense that you inverse cosine that stuff to find your theta?
Do you want it to 1 decimal place?
Huh?
Is it to 1 decimal place, the angle?
Yeah, one decimal place for angles, yes. Thank you. Are we doing okay? .6 degrees. So there's a 28.6 degree angle between those two vectors. How do we feel? Okay, so let's reason through something here for a minute. Let's say my vectors look like that. Noticeably, what do you see about my two vectors I just drew?
2-dimensional.
They're right angle. They are two-dimensional. They could be potentially 3, but they are a right angle. Do you guys agree? So if I was potentially looking for if I'm looking for the angle between these two vectors, and I'm thinking about, I don't know anything more than I know that cosine of theta is equal to the dot product divided by the length of A, the length of B. Y'all told me it's a right angle. What would that equate to? Thank you, hon. What would that equate to in degrees? Like, if it's a right angle, what is that? 90 degrees, right? Okay. So what's going to cause this to become 90 degrees? So I need to kind of think about that for a minute. Cosine, so we're going to solve. I'm just going to kind of show you. Theta would be cosine inverse of what to cause that thing to become 90 degrees? What is cosine at 90 degrees?
Pi over 2.
Let me take out my handy dandy unit circle. Let's think about this for a minute. What is cosine at 90 degrees?
1.
0? Yes, no, maybe so?
Is it?
0. 0. You can't see it on my beautiful, is it because it's too tattered?
It's too old.
Shucks. Pi over 2, 90 degrees, cosine is 0. Cosine is always the x value, yes? So 90 degrees. So let's think about this for a minute. What's going to cause this to zero out? The top has to be 0. So there's a theorem that says if the dot product of two vectors is equal to 0, it's perpendicular. 100% perpendicular. Did that make sense what I just said, huh?
The vectors are perpendicular to each other.
Correct. So if the dot product, because if the top guy zeroes out, then the whole thing is 0. 0 divided by anything is 0. Inverse cosine of 0 is 90 degrees. That's what I'm looking for. So, back in the day, we didn't call it perpendicular. We called it orthogonal. I don't know whether you care about that, because maybe you do. Someday, if you're in a math class, some of you will still take math, the word orthogonal might come out. Orthogonal means perpendicular in vectors. Okay, so understand, I don't believe they will use orthogonal here. I don't believe they will use orthogonal here. But just in case, I don't want you to ever get to a point where you're like, okay, yeah, how did that work? Okay, so I'm going to give you two vectors, and I'm going to tell you they are orthogonal. Give it. They're perpendicular. See, I'm going to tell you that A is 6, -2, and 5. And I'm going to tell you B is A, 4, and -2. So 6, -2, and 5. A is, so B is A, 4, and -2. Can you solve for A? What had to happen for this to be perpendicular? I'm telling you those are perpendicular. What had to happen for that to happen? The top has to be 0. What is the top representing? The top is representing this stuff here, yes? The top is the first, the top, middle. Hmm? So you're, say it again.
You're gonna set the dot on equals.
Correct.
Is that
A is an apple.
The A on the outside and the A in the, like, inside of the B.
They don't
they're
matter to
related.
each other. If I was smart, I would have said, let's call this guy U and let's call this guy V. So then we never would have had to think about that. But apparently I'm not that smart. Today I'm not that smart. All right, how do we feel about this so far? No, yes? So we're gonna take 6A plus -2 times 4 plus 5 times -2 and set that equal to 0. Are we cool with that? Why is it 0? Because the only way that that's gonna happen for it to be perpendicular is if the dot product is 0. So we have 6A minus 8 minus 10 is 0. We have 6A equals 18. A is 3. How do we feel? Are we cool? We're good. Okay. Yay. All right, let me give you another kind of example. Oftentimes we call position vectors by symbol letters. Sometimes they're given in this format, and I'll talk to you about that in a second here. Okay, if I say just U or V or A or B, it is from 0 to that. Sometimes it'll just be very blunt and say, look, we're gonna start at 0 and go to P. We're gonna start at 0 and go to Q, okay? So it's just another way to write a position vector. Starting at 0, moving to a letter out in space. Okay, so O to P, O to Q are both ones that start at the origin and move their way in some direction. This guy, has some unknowns, and so does that guy. I'm going to tell you that K is a constant, so it's just some number. I'd like to know what the value of K is that produces perpendicular vectors here. I want to know how they could become perpendicular vectors. What letter K, what value of K would allow that to happen? Bless you. 5K times K plus negative 3 times k plus 2, yes? And then 7k plus 9 times negative 1 is 0. Are we good? So this is going to be 5k squared minus 3k minus 6 minus 7k minus 9 is 0. Are we good? 5k squared minus 10k minus 15 is 0. Divide everything by 5. So k squared minus 2k minus 3 is 0. And if I factor that out, I got k, 3, and 1. So my two values of k are 3 and negative 1, both of which would produce orthogonal vectors. Are we cool? Could you, if I told you that, let's say k is 2, could you find the angle between those two vectors? Yes. If I told you that k is 2, could you find the angle between the two vectors? Let's go ahead and try that.
They won't do that on the test, where they'll be like, hey, find k, but then we're gonna give you a value of k.
Yeah.
But it's not the same.
Well, because this has, they're perpendicular for sure. When I plug in a 3 here, it's gonna cause perpendicular. When I plug in negative 1 here, it's gonna cause perpendicular. But if I give you a 2, it's not perpendicular, it's just gonna be two randoms in space.
Okay, that's what I was like, why would we?
Right.
I got it, yeah.
Okay.
We're finding the angle. Oh, between those two. Yeah.
I'd probably cry. Really?
All right, how we doing? I still wanna know what dentist gives you lollipops after you
So
go.
where did you go, Ben?
When I was like 5,
Mm-hmm. I don't know. She, so, you have a name?
yeah, look at the
Oh,
edge.
he's on the roof.
Just like at the tip.
I think the left part's the actual thing, and then the outside is just.
Nah, it tastes different. Lick it. It doesn't taste as sour.
Yeah.
What?
97.
97.
Alright, who was right?
I got 97.9.
I guess if we.
Point what?
Hey.
I got 97.97.
And you got 97 point
I got 97.0.
0.
I got 97.94.
Oh.
I like how it's.
Hey.
I got .97.
Okay, are we in the ballpark of 97 degrees?
Yeah.
638.
I got 97.4.
I got 620.
What is that?
You cool.
Me too.
I got 620. I have negative
You should have
9
given us these ones, though.
somewhere. I don't know.
You square.
Tastes like sugar? Wow, that's a good observation.
My calculator told me for that one, 2 root 155. That's what it put out.
I don't know how to help that.
Did you also have 620? Did you also have 620?
I don't know.
Would you?
Put it in and it
said
said
2
2
root
root
what?
155.
Are we cool?
I mean, I got 97.
97.4?
I got 97.94.
Oh, that don't sound right.
I really don't.
Okay.
Oh, actually, no.
That's a way to wake you up. I'm telling you.
So it's like,
Bro, I am like 2 words in.
there's a picture.
I'm bad at picture. Yeah, 'cause you don't have to really use.
No, this one's okay.
It's
This is
irrational.
Just because I can't draw.
Is it supposed to be straight?
It's a
Yeah.
It's not on the scale.
It looks good to us in this case.
That's worse. Sorry.
Oh, you're not supposed to add.
Okay, you are going to be given vector OA and vector OB. How do you find AB in space? It doesn't start at 0, 0, 0. AB goes from here to here and forevermore, okay? So, AB is equivalent to, and I'm always gonna say this is how I remember it.
This is like for all, anything that looks like this.
Yep. Yeah, and we'll do an example in a second. So, AB is always gonna be
What are we finding?
AB, the length of AB, like what is AB? What is my vector AB? So, the way you find AB is you take, always think of the last guy that happened. So the last guy is B, right? So you're gonna start with the last thing. It's OB minus OA. Okay? That's the formula for that. So, we're gonna try to find PQ, given our information we have here.
Oh,
What's the last guy that we have in that?
and it looks like that.
It looks just like that.
Alright.
Okay.
So where do we start? We go OQ minus OP. And OQ has 3 values. Are you guys cool with that? And OP has 3 values. So are we able to find PQ? Well, sure. It's going to be, PQ is going to be 2 minus 10. I'll just work it out for you. 4 minus -3, and then -1 minus 23. So what is the new vector that makes up, in this case, PQ? -8, 7, and -24.
Will you always know that anything with like an OP or OQ, let's say it's like a different letter, will you always know that it's going to be triangle like that because
Yeah.
it has O in it?
Yeah, starts at the origin. So let me give you, because this is like the end result. But let me show you, because this is kind of helpful and it may be helpful in our homework. If I'm looking for AB, okay, some of the ways that I can get to it is AO plus OB. That's one of the ways. We rarely use that. Rarely use it. Okay. Because do you agree with me? We start at O and work our way to A. So if I flip this, I would negate it. If I flipped it, I would just make a negative of it. Okay? So if I'm looking for QO instead of OQ, this would be negative, negative, positive. It's just the opposite symbols. Alrighty? If I kind of clean this up a little bit and flip it, what does that look like? OB minus OA. It's what I started with, right? So that's how this happens. Just in case you need to have a reason for it. But for me, I say second letter goes first, subtract the first letter, you got your thing. That's how my brain works. All right, how do we feel? Okay, so we will start working on our homework tomorrow or tonight, remember? And you have